All right. Looking at analyzing the shapes of graphs using the derivative here in standard 12. Today's lesson is on what's called the first derivative test. How can I tell what the shape of a graph is based off of the first derivative? What does the first derivative tell us about the shape of a graph? Looking up on the television screen, let's look at this graph for a second. I just have the graph of a basic polynomial. I've adjusted the sliders over on the left to make it look like this because that's got a lot of kind of what I want to talk about for a given function. I can select some of these check boxes on the left side to show where our function f is increasing. So in blue, I can see where the function is increasing. Select decreasing, and then in yellow, it's highlighted where the function is now going down from left to right, yeah? What would the sign of the derivative be if the function's increasing? I think we talked about this before back in a previous standard where I had you graph the shape of a derivative given a particular function. The sign of the derivative, if the function's increasing, is what? Positive. Let me select both of these, and I can also highlight f prime of x for this given function. In blue, where the function's going up from left to right, the derivative would be positive above the x-axis. The slope of the graph, the slope of the tangent line, is positive. If you can imagine a tangent line, what that would look like. On the part of the graph that's highlighted in blue, it'd be going up. A tangent line or a slope of the graph is positive, so therefore the derivative for this part of the function should be positive as well. That's what this first bullet point is talking about. If f prime of x is greater than 0, or therefore positive, for all x values on some interval, that means that the function is increasing on that interval from a to b. Vice versa, here in yellow, where the function is decreasing, now the first derivative has dipped below the x-axis and is now negative. The tangent line, or slope of the graph, would be negative, have a negative slope. If I just kind of fit a tangent line here, roughly to what this graph is, it's going down from left to right. Therefore, if f prime of x is less than 0, if the first derivative is negative for all x values in some interval, then I know that f of x is decreasing on that interval from a to b. Our work yesterday, what did I call this point here on the way top?
Absolute maximum.
Yeah, our extrema, right? Maximums and minimums. What's the value of the derivative at any extrema, either a max or a min? 0. That's where it changes directions, right? That's where the sign of the derivative changes from positive to negative or negative to positive. At this maximum point, how does the derivative change? From positive to negative or negative to positive? How does the derivative change at this maximum point? Right. I go from going up to going down. So doesn't the derivative have to go from positive to negative? That's what this is telling us here. If f prime of x, if the derivative changes from positive to negative, if the graph goes from increasing to decreasing, in other words, at a given point x equals c, then that point, c comma f of c, is a relative maximum of our function. If the derivative changes sign from positive to negative, that means the function goes from going up to going down. And don't you have to top out somewhere? If I go up, then down? Pretty much. Vice versa, how does the derivative change at this minimum point? Does it change from positive to negative, or now negative to positive? Which one? At the minimum. Right. Negative to positive. If the derivative changes sign from negative to positive at a particular point x equals c, then that coordinate c f of c has to be a minimum. I go from going down to going up. So don't I bottom out somewhere? If I go down, then back up again at some point? All right, so this is what's called the first derivative test. All the different key attributes, or how we can use the first derivative to describe some interesting aspects of the shape of a graph. How can I tell where it's increasing, decreasing, where any relative maximums and minimums are at, using the first derivative? Let's apply that to a particular function as a good example here. So, determine the intervals where f of x equal to x squared minus 4 to the 2/3 power is either increasing or decreasing. We're going to use the first derivative test. I want to basically answer where the derivative is positive or negative, and that will tell me where it's increasing or decreasing. And I also wanted to use that information to find any relative extrema of f of x, because I know if it changes from increasing to decreasing, it has to be what? Going up to going down. Is that a maximum or minimum? Max. And if it goes vice versa, down then up, that has to be a minimum. If there changes sign from negative to positive, it's a minimum coordinate. Okay. So let's first find critical numbers. Critical numbers are where the derivative changes sign. In other words, it's equal to 0 or undefined from our definition from yesterday. Critical numbers are where the first derivative changes sign for a given function. So let's find f prime of x. The derivative of f of x equals x squared minus 4 quantity to the 2/3 would be what? Use power rule. 2/3 comes down. Then it's the same quantity x squared minus 4 to a new exponent. What's 1 less than 2/3? Two-thirds minus 1.
Negative.
Negative 1/3. That's half the story. I'm going to now multiply times the derivative of the inner function, according to the chain rule. So the derivative of x squared minus 4, or 2x. See, I can probably clean this up a little bit. Multiply 2x times 2/3. So that's 4x over 3. And then bring down the negative exponent, 3 cube root of x squared minus 4. All right, critical numbers. There are two ways to have a critical number, where f prime of x is equal to 0, or where f prime of x is undefined. When I have a rational function, I'm going to set either the top or bottom to 0 to find these two types of things. 0 divided by anything. What's that always equal to? 0 divided by anything is always what? 0. So as long as the top is 0, does it really matter what the bottom is? If I know the top is equal to 0, what does that guarantee? The whole thing is equal to 0, right? So I know my derivative is equal to 0 whenever the numerator in this rational function is 0. So let's set 4x equal to 0. Obviously that occurs where? 4x equals 0 when x equals 0. So there's one critical number. I know that the derivative changes sign at 0. Because the derivative is equal to 0 at 0. Okay. Now let's work on the next portion. Where is the derivative undefined? Anything divided by 0 is what? Anything divided by 0. I know that 0 divided by anything is always 0. Now let's just reverse that. What is anything divided by 0? Undefined. So if the bottom portion is equal to 0, does it matter what the top is? I'll know that the derivative must always be undefined. So let's set bottom equal to 0. 3 cube roots of x squared minus 4 to 0. divide by 3. How do I get rid of a cube root? Cube both sides. Cube and cube root cancel themselves out. That should leave me x squared minus 4 equal to 0. Any guesses where that's going to happen at? I could keep solving, but maybe we can kind of figure it out for ourselves by now. 2 and -2, plus or minus 2. 2 squared is 4, 4 minus 4 is 0, so that sounds right. -2 squared is also 4, and 4 minus 4 is still 0 again. We have 3 critical numbers at 0 and plus or minus 2. I know the derivative changes sign possibly at 0, -2, and +2. So in part 2, let's test f prime of x. I want to see within these intervals, is the derivative either positive or negative? If the derivative is positive, what does that tell me about my function? If the derivative is positive on a given interval, it's going which direction? Increasing or decreasing? Oh, if the derivative is negative, it's just going down. I have 3 critical numbers. Let's make a number line. -2, 0, and 2. I know that those are the only 3 places where the derivative can change sign. It never changes signs anywhere else. So if I can test the first derivative within any of these intervals, I can therefore tell if the derivative is always going to be positive or negative on these intervals. Think of a number that is going to be less than -2. What's a number less than -2? -3. Let's plug -3 into this derivative. F prime of -3 would be 4 times -3 divided by 3 cube root of -3 squared minus 4. I'm not really interested if this is what this exact value is. I just want to know what sign. Is it positive or negative? What's 4 times -3? Is that positive or negative? Obviously. Negative, okay. -3 squared is 9. 9 minus 4 is 5. Is 3 times the cube root of 5 positive or negative? 3 times cube roots of 5, positive or negative?
Positive.
Positive. What's a negative divided by a positive?
Negative.
So that means that my first derivative is negative for that entire interval, from -infinity to -2, for everything less than -2. Think of a number between -2 and 0. Give me another number. Let's plug in -1 now. I'm going to test the sign of this first derivative. Is it positive or negative? Because that will allow me to see if it's increasing or decreasing, like this first question asks. Where is this function increasing or decreasing? So 4 times -1 over 3 times the cube root of -1 squared minus 4. 4 times -1 is negative. -1 squared minus 4, that's 1 minus 4, that's a negative. 3 times the cube root of -3, is that going to be positive or negative? 3 cube roots of -3, is that positive or negative? Cube roots of negatives should still be negative. So I believe this is now negative in the denominator. A negative divided by a negative is positive. -2 is a critical number, so I'm fairly certain that the derivative should change signs at -2. If it was negative before -2, it's probably going to be positive after -2. That's where it switches signs. These usually bounce back and forth. Let's test 1 again. 1 is a number between 0 and 2, so let's test the sign of this next interval. Run out of room here. F of 1. That's 4 times 1 over 3 cube roots of 1 squared minus 4. 4 times 1 is positive again. 1 squared minus 4 is a negative number, -3 to be exact. 3 cube roots of -3 is negative again. Top is positive, bottom is negative. Want to divide the 2, negative again. Think of a number greater than 2. Let's test the next interval from 2 to positive infinity. Right, 3. I don't care what these numbers are, I just need to know what sign they are. Because that will tell me what the sign of the derivative is going to be. We're testing f prime of x. This is a number line for the sign of the first derivative. 4 times 3 over 3 cube root of 3 squared minus 4. 4 times 3 is positive. It's 9 minus 4. 3 cube roots of 5. Is that positive or negative? Positive. Positive divided by positive, still positive. Use our notes from the other half of the board. From -infinity to -2, is our function increasing or decreasing? You know that why, Caitlin? The sign of the first derivative is negative. From -2 to 0, our next interval, is the function increasing or decreasing? What's the sign of the derivative from -2 to 0? So is it increasing or decreasing? From 0 to 2. Obviously, I'm going to go back to increasing or decreasing. Decreasing, and then increasing after that. Start writing down our answer. We are increasing from -infinity to -2, and from 0 to 2. Wait, I wrote that wrong down. We're decreasing on this interval. On that? Because isn't the derivative negative on those two intervals? And then positive on the other two. So it's increasing from -2 to 0. That's where the first derivative was positive. And from 2 to infinity, also where the first derivative was positive. What happens at -2? Because now I need to see if there are any relative extrema, any maximums or minimums. What happens at -2? How does the derivative change around -2? The derivative goes from negative to positive. Does that mean I have a minimum or maximum reading the notes from the other half of the board? Minimum. If I go from decreasing to increasing, don't I have to bottom out somewhere? So there is a minimum at 2 comma something. Let's find that minimum value by plugging 2 back into the original function. X equals 2 produces a minimum value for this original function. So 2 squared minus 4, that's 4 minus 4, or 0. 0 to the 2/3 should be 0. There's a minimum at 2, 0. Where else is there a minimum? Oops. At -2, right? Why -2 though, Shay? Right, it goes the same sign change. Negative to positive around -2, negative to positive around +2. So I plug -2 into here. -2 squared is 4. 4 minus 4 is 0. 0 to the 2/3 is still 0. These are not intervals, these are coordinates, right? The difference here, these are intervals of numbers, these are just actual coordinates on the graph. Sometimes people get those confused because they both kind of look the same. Where is there a maximum at? Where does the derivative change from positive to negative? 0. I go from increasing to decreasing. The function goes from going up to going down, so it has to top out somewhere. It has to have a maximum point. We have a relative maximum. At 0, what is that? Negative, let's see, 0 squared is 0. 0 minus 4 is -4. What is -4 to the 2/3? That's going to be some random decimal. 2.52. Approximately. The intervals where our function was increasing or decreasing, and I used the sign of the derivative and how the derivative was changing to identify any relative minimums or maximums. Let's just make sure that this corresponds with the graph that I could quickly just type in the Desmos. Here's the graph of x squared minus 4 quantity to the 2/3. It should be decreasing, increasing, decreasing, increasing. Decreasing from -infinity to -2. Increasing from -2 to 0. Decreasing again from 0 to +2 on this interval. And then increasing again from positive to positive. How many relative minimums are there? There are 2, and they are both at -2 comma 0 and +2 comma 0. The derivative changes from increasing to decreasing at x equals 0, telling us that there's a relative maximum. So at 0 comma f of 0, 0 comma 2.52, there should be a maximum, relative maximum for the function.